Welcome to my channel. The universe is vast and full of diverse objects. They are so far apart in space that even light gets lost. Photons from the Sun take 4 years to reach our nearest star. Covering intergalactic distances takes millions of years. It's amazing to realize that all this distance is a molecule in macrocosmos. What is the first spacecraft's true size? The solar system is one of many planetary systems in our galaxy. As far as we know, it dates planets with satellites using a single main sequence star. Our system also has over 1 million asteroids, comets, and meteoroids. Neptune is the farthest known planet in the solar system. The orbital radius is 30 astronomical units, or 4 light hours. Amazingly, only a small part of the solar system is surrounded by Neptune. Far, far out is the system's farthest object, 132 astronomical units or 18 light hours from the Sun. Even this barely visible object against the dark background of unfathomable space is far from the hypothetical Oort cloud, whose inner boundaries are about 2,000 astronomical units from the center of our system. Some estimates put its outer boundaries at 60,000 astronomical units. Around 1 light year, the Sun's gravity defines these limits, and interstellar space lies beyond. Over 50 stars of all kinds will appear within 20 light-years of the Sun as we move away. These stars range from dim, cold brown dwarfs to bright, well-known stars like Sirius, Procyon, and Altair. Some of them have planetary systems with life-sustaining objects like Gliese. 832c, 16.1 light-years from the Sun, is closest to Earth in the solar system. The exoplanet orbits its parent star in 36 Earth days and has an average surface temperature of 253 Kelvin, 20 degrees Celsius below zero. Our distance from Gliese 832c is small, but a space probe leaving our system at 17 kilometers per second would take as long. At our current technological level, it is impossible to design an interstellar spaceship that can travel as far as the solar system and its neighbors, which are part of the Orion Arm, which is part of the Milky Way, which contains 400 billion stars and potentially over 1 trillion exoplanets of all kinds. Around 100,000 light-years, and the stellar halo may be twice as big. Despite the galaxy's 1,000 light-year main disk thickness, a bulge is clearly visible in its center. The bulge is about 3,000 light-years thick. The local group includes the Milky Way. This massive structure contains over 50 galaxies in a 10 million light-year area. The Milky Way, Triangulum, and Andromeda galaxies are the largest. Some estimates suggest that the cluster may have 3 trillion solar masses, with our galaxy and Andromeda making up the majority. Andromeda, excluding dwarf galaxies, is our closest galaxy at 2.5 million light-years. Next, the local group is part of the Virgo supercluster, which has over 30,000 galaxies. The supercluster is in a space with a diameter of about 1.5 billion light-years. It has a quadrillion solar masses, or about 1,000 Milky Ways. Even though it appears staggering, the supercluster is flattened, and 60% of its objects look like a flat sheet 10 million light-years thick. This value is small compared to the universe's large-scale structure. We can see a giant supercluster of galaxies 520 million light-years away if we zoom out more. Virgo and the Great Attractor are among the galaxy's superclusters in Laniakea, which is years long. The formation has about 100 quadrillion solar masses. The Great Attractor, 250 million light-years from Earth, is the gravitational center for all nearby objects. The Milky Way blocks direct observation from Earth, so the Great Attractor's nature is still unknown. Laniakea is part of the universe's massive galactic filaments, walls, and voids that create vast empty spaces. Some of these are massive. For instance, the Hercules Corona Borealis Great Wall spans 10 billion light-years. Since its discovery in 2013, this superstructure has been considered the universe's largest large-scale structure. Millions of galaxies and their stars will likely remain uncalculable. The existence of a structure like that is a mystery to science, as gargantuan clusters like that are not supposed to form. But this wall so massive that the human brain cannot fully appreciate its dimensions is still just a tiny portion of the observable universe. current cosmology holds that space in the universe is constantly expanding, speeding up based on distance between objects. The farther an object is from the observer, the faster it grows. The two objects will become unobservable at a certain point because space matter is expanding, not light. According to relic radiation observation, the universe is a sphere with a diameter of about 93 billion light-years. According to relativity, we can only see and interact with objects within this sphere for years. The metagalaxy is a conventional spherical area in space that may be the entire universe, or a tiny portion of it. Hypothetically, there may be unknown structures beyond space's visible boundaries. Extra-metagalactic objects cannot be studied scientifically today. The edge of the visible universe appear to be moving differently than expected. According to the data, anomalous movements may indicate the presence of massive structures beyond the matter galaxy boundaries, whose attraction permeates space and affects nearby objects. A lot of hypotheses about the structure of the universe beyond the metagalaxy are metaphysical. Some believe that time, space, matter, material, and energy are meaningless outside the universe, as are our physical laws. Idea. This hypothesis is expanded by the metagalaxies are part of a more complex and larger superstructure in space whose composition and dimensions are unimaginable. This structure may be multidimensional, or be based on unknown physical principles. This makes metagalaxies a minor part of this mind-boggling superstructure. Some interpretations of the anthropic principle suggest other worlds beyond the visible universe. These worlds have different values for fundamental constants like light speed and electron charge. Multiverse theory supports this hypothesis in many ways, which schematically looks like foam with many bubbles separated by impenetrable thin walls. This makes every universe a separate space with its own physical laws, which may be completely different from ours. The most extreme hypotheses deny objective reality. These say the universe is a simulation like virtual reality in computers, but on an extremely advanced level. Ideas like that imply that there is some superbeings or super civilizations exist beyond our reality with infinitely higher advancement and incomprehensible goals and capabilities. However, confirming or disproving these hypotheses is difficult. Space distances defy our imagination and are frightening. They appear infinite to anyone today. The universe is expanding, and we know this. First galaxies, then stars, and the world will be immersed in eternal darkness as time passes, but no one will be around to witness that foreign event.